Welcome back, gangies. We've come down with another sickness. I've been feeling a bout of dull nausea for the last 2 days. Hopefully it will subside soon. Unfortunately, I have no idea what it could actually be. I have some ideas, but the ideas require I have not been in contact with fecal matter. I don't know why that's such a funny statement, but based on what Google is saying, the symptoms are explainable if I've been in contact with fecal matter. I have not, so it's unclear. It's unclear what the reason is. Hopefully, it's just the remnants of the sickness. I'm wondering, maybe we'll start another channel soon. They need a medical equivalent of LeetCode, so we can just do a bunch of medical diagnosis problems. And that'd be pretty cool. Maybe we need to do that because ChatGPT and all these other tools are going to pretty much fix everything that's wrong with the education system. Presumably, if we cannot just force people to regurgitate and paraphrase paragraphs anymore, we'll have to force them to learn skills, which is kind of lame. So imagine a school where instead of actually writing nonsense, you're out there actually in the field learning some actual skills. Could be kind of crazy. Imagine graduating high school, but you already know how to program. Instead of, I know a lot of high schools do like introductory program and stuff like that, and there's APCS and stuff like that. But I mean, coming out of school and being like, oh yeah, I'm going to boot up some Docker containers, set up some Terraform. That would be pretty cool. So it'd be pretty cool if things change like that. But it seems like the only valid option or the way through at the moment, at least. So hopefully someone in the government jumps on that. Otherwise, we're finished. The other reason I think I could be sick is that I think that the mucus that I'm producing has a direct line to my stomach. And that may be why we're still feeling some nausea, even though I'm not coughing anymore. That being the case, we have no idea. So if I don't upload, if I stop uploading abruptly, the HCC, someone has to take the baton and keep going. But if I stop uploading, there should be a reasonable cause for concern. That being the case, we have more LeetCode to do. We're being bested by a foursome problem, but fortunately we have some comments that are going to help us burn some time before we must recede back into our cave to perform. We're actually catching wilderness here very, very recently. 10 minutes ago, the comment was posted. And there's nothing like seeing Gon's face that doesn't just make me ready to actually train our Nen. So that is pretty dope. It burns me out that we take all this time developing a skill for what ChatGPT. It's actually funny that we're thinking about the same thing that ChatGPT spits out in seconds. I still want to pursue LC, but I think it has to be supplemented with a pertinent skill/business. You need to make money off of everything you are learning. Very fair point. It actually crazy that we're on the same. I promise I didn't pre-read this comment, but it's very interesting that we're on the same page. I agree. I think that's why it's not because of ChatGPT specifically, but I used to do long sessions, and granted, if you have an interview coming up or you have an interview with a big company or you just have something big coming up, you can't avoid the LC grind. It is what it is, at least a little bit. But I think I don't put as much time into it, particularly because we gotta have some skills too. So in the cases where I found that I could be doing more LeetCode, I always also think that, if I could do an hour of LeetCode, should I do an hour of LeetCode or should I do 30 minutes of LeetCode and then an hour of some Terraform or AWS or something? And usually it balances out that expanding on current skills or expanding on areas that I'm not comfortable with seems to be kind of the better cost value action. But also, I'm currently employed, so that's definitely some privilege speaking there. So I know based on what people have going on, it's definitely going to depend. So, but yeah, I definitely agree. We must find a way. I mean, I don't think we should monetize everything we do, but the current state of the market, CS is definitely CS is definitely in need. CS is definitely paying the big beans. So what else can we do there except accept our fate? So yeah, I think it's just true. I think it's just true. So yeah, I've been sorry if I'm a little slow today. I'm still not feeling very well, but yeah, it's just true. Must be a way to, yeah, and I think that's the other tough part, because it seems like an arms race that you have to be prepared for, right? Because now, I mean, it depends. You got to pick a couple things and just, there's always going to be ways to be overwhelmed. But I was thinking you have to be like good at LC, you have to have a resume, you have to have a portfolio of projects maybe. You also have to have some good stories to tell prospective employers that, you know, you're a functional and competent human being that can solve problems, undefined and defined. Kind of messy, but at the end of the day, maybe we just pick a couple things and try to max those. But yeah, I agree. It is a little bit nutty to do this and spit it out, and it spits it out. So, but yeah, I truly, I don't know if we'll have a better option anytime soon. I feel like tech interviews will just always be like this. Maybe they'll be worse, right? I think it would actually be worse if it was like, hey, set up a repo of infrastructure as code or something. That sounds pretty dog. But we do indeed, yeah, I agree. I don't really know. There's not a lot to say here because it's just true. We got to be grinding. There's definitely going to be a there's definitely going to be a point where there's diminishing returns on doing more LC. And at this point, I think we're just doing LC1 because I'm going to be honest. Making number go up, make number go up, make me happy. Simple as that. And unfortunately, I feel like we need to get this number to finished, and then I think we'll be relatively satisfied. But also the problems are kind of fun now, so I'm also just here for the journey. So that could be pretty cool. Even though every day I think, what if I just... Even though I still think every day, what if I just don't upload? I just don't upload at all. It's just very interesting. It's just an interesting thing that I still think that even after all this time. But we've already set a precedent on all the other days where we did it anyway, even though we didn't want to. So it just be like that. But yeah, I agree. So we got to get some skills up so we can get our bills up. And then we have a legendary comment from T. Wong, the God King, the God Beast, fellow Nen practitioner along with Wilderness. Foursome, right? Ha ha. True. True. I just agree. It just be facts sometimes. It's just true. So yeah, that being the case, the last 4 days I haven't been doing too much supplemental learning outside of work. TBH, I'm going to keep it a stack 1,000. I think the last week or so at work I've been doing so much learning that the supplemental learning felt like achieving for the sake of achieving. But it felt like we had already learned so much. I'd already learned so much during work that watching an hour-long video on RDS after work seemed a little bit nutty. That being the case, I can stall no longer. It's already late. I haven't eaten yet, and we must begin. The suffering. I think we're slowly getting close to this twosome problem. It remains to be seen, though. But we should jump into it. As always, thank you to everyone for commenting, specifically Wilderness Thomas, as well as everyone else who didn't comment today, but usually comments. To feel strong, man. To feel strong, man. So I'm going to kick off the timer. I'm going to set it for 20 minutes. I'm going to keep it a stack 1,000. But also, on Fridays we do a shorter session anyway. But also, I'm sick. And I'm not feeling well. So we're just going to put in the 20. If we go longer, we do. If we don't, we don't. So let's set a minimum bar. So similar questions, 2-sum, 3-sum, 4-sum, to count special quadruplets. I want to click related topics, but I feel like it's going to give the problem 2 pointers, sorting, array. Okay. We already considered sorting yesterday, and we considered a 4-pointer approach. I didn't consider a 2-pointer approach, though. Basically, after we generate this n by n, oh wait, now I think I figured out what we were trying to do. I did a version of this that's taking too long, and we're actually only getting a slight TLE. I'm wondering if we do one more optimization, if we can squeeze through to the solution, and I'm betting we might be able to. Actually, here we're just getting the wrong answer. Right, because I said unique indexes dot size equals 4. This actually bites us in the case where the string needs at least one set of all of them being the same. Yeah, it's actually what's going on here. I've used this version before and it seemed to be working fine. Oh. In fact, I think we could squeeze through if the LeetCode load is a little lower than usual. Yeah, I don't know what is going on. I'm just going to revert to this version. I'm not exactly certain what I've changed that's giving us difficulty now. In fact, we're not even using paired nums above. So it is actually unclear why this is failing. I'm just going to copy this whole block. Or can I, is there just a restore submission button? There's not. Okay. The issue seems to be we have multiple, for some reason this takes forever. We also do have a lot of like values that are divisible by 10, so it's probably adding a lot of issues, especially with the target being 200. So for iterating over paired map, and paired map is going to be, there's not going to be that many in paired map. We check the problem description. A, B, and C, and D are distinct. Okay, so if they all have to be distinct, they all have to be distinct, then we might be able to just skip the nonsense. Because I'm doing some indices, some and some indices over paired map. Now, if we have the complement, which means it sums up to thingy, we could make this faster by not considering, we're saying I does not equal J. And I think I had before, num sub I does not equal num sub J, right? Because we want distinct. This makes us fail on this case. In the case where we're actually not even using paired nums at all, I think. So what if we did something like this? Can we even fix this? We're saying when all the values in the number array are the same, there can only be one answer, which is true. Now what if only one value was different? If there was one value that was different, we could probably, for example, if there are a bunch of zeros, we could say 0, 0, 0, and then the different value. If the different value was the target. The current implementation. Would the current implementation allow that? I don't think I'm understanding, because we still have 2 zeros here, which means that they don't have to actually be distinct. The numbers in the array themselves doesn't actually have to be distinct. The indices that they live from in the array actually have to be distinct. And the quadruplet must actually be distinct. So if I add, if num sub I does not equal num sub J, I'm not helping myself because we're taking out since the quadruplets must be distinct, if we only act like, if we see 2, for example, if we see a number that sums up to 2, and there are multiple ways to get 2, we need the multiple ways to get 2 because they could be formed by unique methods. but maybe it doesn't matter because we're looking for distinct quadruplets as well. So if we throw out the different ways to sum 2, are we really losing anything? All that we really care about is that there's a number we can now add. Either way, it seems like we don't want to throw these out. So here we try to take all the values that sum up to sum, and all the indexes that were used to create the sum, and all the indexes that were used to create the complemented sum, and then we pretty much like matrix multiply them together. We sort them. No, sum tuples would be right. Yeah, we pretty much matrix multiply them, generate all the combinations. Something feels incomplete here. I feel like I'm missing something. What if we scrap this whole thing? Not the whole thing. What if we scrapped n squared time and aimed for n cubed? To do n cubed, we just have to add another for loop, right? And we could add another variable k. I'm thinking this would work, since then we could just take the individual indice and check if we subtract it, target from it. Do we have target in this map? And j does not equal k, and I does not equal k. Yeah, let's try that. Here we can do for const Oh no, I'm delusional. I'm trying to iterate. I want to do something like for const let I equals 0, I is less than nums dot length I plus plus. Num will be num sub I, and target will be target minus num. Then we can say if paired map has complement, then we have a 3 pair that could work. Additionally, we'd like to remove the current indice. What I'd like to say is we'd like to say indice set would be equal to I and triple. Let me think about this. Either way, it doesn't make any sense. We're taking an index here, and we're going to look at a sum, right? It completes the target. If we look at it, and there's probably multiple ways to get this sum. So it probably is fine to look at them. Now that I'm thinking about it might actually be simpler if we just iterated over the paired map itself. I think is what we were trying to do before. We had sum This is not the way. This is just not the way. Either way, you end up doing a bunch of nonsense. What if we sorted it? Considered this last time. If you take this array and then you sort it, you get -2, -1, 0, 0, 1, 2. I thought about a solution where we could have four pointers, but then it's unclear when they should be moved. I guess if it's sorted, we know where to move each one of them, right? Because we'd like to move we'd like to move the pointer closest to I guess we could break it down to cases. If our current value is some amount, if our current value is less than the value, then we have to increment somehow the pointer on the right hand or the left hand side. If we're less than it, to increase in value. Maybe we could apply a four pointer approach with heuristic. Four-pointer approach with heuristic. For example, what if we started at 1? What if we have 4 pointers, so we'd have a pointer at the leftmost point. Well, how do we choose the number we're starting at? Let's just say our target, if our target is 0, we should probably We should probably start it where? Actually, what if the leftmost pointer just starts at the left? What if we do the leftmost pointer is where we start? If we start with -2 and we know we start with -2, and let's just say the other pointers are just at -1, 0, and 2. That gives us a sum of -1. We'd like to get -1 to 0. I guess it depends, right? Where is our number in relation to target? If our sum is currently at, actually, if we were to place this, we'd have -2, -1, which would be 3. Yeah, we'd be like this. -2, -1, 0. And then presumably the rightmost pointer would be rightmost at 2. This would give us a sum of 4. I mean, -2 plus 2 is 0, plus -1 is -1, plus 0 is -1. -1 is less than our target. If it's less than our target, we should move our second pointer right. We should move our third pointer to the right one. It's still less than it. We add 1 again. Now it's equal to it. So we're actually equal to target. Nah, 4 pointers is crazy. It doesn't make any sense. Wait a second. What if we use two arrays? Well, one array sorted, but 2 sets of 2 pointers. One would be at the leftmost portion, one would be at the rightmost portion, right? And they cannot equal each other. What we would really be doing, they both can't be at the leftmost and the rightmost, otherwise they'd always run into each other. So what if we just half the array? That way our left and right pointers never overlap and they could be bounded, but we could still have 4 unique options. So we'd have -2 and 0 to start, and then you'd have 0 and 2. Oh, where should they? Well, they start at the left. Okay, so if they start at the left and rightmost points, then it already equals 0. So we would add. It already equals target, so we would add 1 there. It seems like it won't work because we need to also, this doesn't make any sense because we would need to, I feel like we need to exhaustively to find all the unique ones. How can you not do this without an optimized, exhausted version? I don't see how the 2-pointer part optimizes this. What if we did brute force optimized instead? That way we could give up on I think I just realized what they're trying to tell me. What if we combined both of the approaches? Original n squared version plus 2-pointer. What if we used n squared operation, right, to generate all pairs of two numbers being added together? If we sorted that, then we could apply 2-pointer on top of that. And this would simplify the whole interface of one number mapping to multiple indices, because now one indice is just one indice. I feel like this is actually the way. I is less than nums.length. I plus plus, we'll turn this into j, and we'll want to say call this tuple sums. It's going to be an array, right, of tuples where the first value is the sum and the second value is the tuple, or the indexes it was created from. Right, we want to make sure that if I does not equal j, and then we'll say tuple sums dot push num sub I plus num sub j. So we'll wrap this in an array, and then we'll say I comma j. Then we can sort all of them in descending order Ugh, this doesn't make any sense. Even if you do it this way, it's unclear why you would use 2 pointers here. We have all the possible combinations of adding 2 numbers together, which means we have to just check if 2 of them add up to a particular sum. If I do that, that would be me checking a value. Oh no, and then we end up where we did before. We could load them into a map. Wait a second. maybe you can do optimized brute force. You have I, J, K, and M. We'll say J is equal to I plus 1, K is equal to J plus 1, and M is equal to K plus 1. If we look at it like this, they should never ever overlap with each other, because J starts 1 in front of I, K starts 1 in front of J, M starts 1 in front of K. We can say if num sub K will only do the work in here if I, num sub I, is less than target. Or we'll say let sum equal num sub I. Right? In here we'll say sum plus equal num sub J. And then we'll say we'll only go into here if sum is less than target. The one thing we do have to make sure is that nums is sorted. And then once we get in here, we'll say might actually be easier to say. Here we'll just say num sub I. Here we'll say to sum sub I plus num sub J. We'll say const 3 sum is equal to num sub. Actually, we can just say 2 sum plus num sub K. We'll say if 3 sum is less than target. Right, then we want to do the work in here. And we'll say 4 sum is equal to 3 sum plus nums sub M. In here we can say if 4 sum equals target, which is an array say return answers. we'll say answers dot push an array of num sub I, num sub j, num sub k, and num sub m. Similarly, the ID for this array, we can already guarantee that they're unique indices, but we need to guarantee that the sum is unique. We'll say the sum ID is equal to num sub I num sub j, comma, num sub k, comma, num sub m. And then we'll say if we have never seen this sum ID before, then we want to 1, push it onto the answer list, and 2, sum IDs add sum ID. And then we'll just create sum IDs. It's going to be a new set of type string. I think this could work. So we have promising reduce in the first 2 cases. So why isn't this working? I think we should change this to less than or equal. That's a good point. Right, and it's when we go over target that we like legit just want to stop. The target is -11. So it looks like this. We start with -5, -4, -3, right? And -2. Well, that would be -12, which is grade. I see. I think the last thing we need to do is just to make sure that the case needs to flip. So if is greater than or equal to 0, or target we'll just call it target pause, or target is not positive and num sub I is greater than or equal to target. Target is not pause and toSum is greater than or equal to target. So the base case should still work as it did before. I think we'll have to come back to this one tomorrow again.